Let's practice on getting a better understanding of the distributive property and rewriting sums and differences together. For this first set of problems, let's go ahead and use the distributive property to go ahead and rewrite each of these expressions as a sum or a difference, and then let's go ahead and evaluate or solve them. For number 1, we have 3 times the quantity of 2 plus 9, or the sum of 2 and 9. And really this 3 on the outside means there are 3 of these 2's. So we can go ahead and write that there are 3 2's, or 3 multiplied by 2. And then we also have 3 of these positive 9's. So we're going to go ahead and write here, we have 3 times 2 plus 3 multiplied by 9, or 3 of those 9's. Now 3 of those 2's is equal to 6, and then 3 of those 9's, or 3 times 9, is equal to 27. So 6 plus 27 is equal to 33. Now another way of thinking about this is we could add 2 plus 9 to get 11, and 11 times 3 is 33, so both ways would work. We're just practicing using the distributive property here. For number 2, we have 5 times the quantity of 6 plus 5. Really there are 5 of these 6's, so let's go ahead and write this is going to represent 5 times 6 plus, because we have another plus inside the parentheses, and we have 5 of these 5, so it's going to be 5 times 5. So we have 5 times 6 plus 5 times 5. Now 5 times 6 first is going to equal 30, and then 5 times 5, that's going to equal 25, so 30 plus 25 equals 55. Again, if we were just using the order of operations or multiplying, or this 5 times the sum, then 6 plus 5 is 11, 11 times 5 is 55, so that should hopefully check out. All right. For number 3, we have 7 times the quantity of 9 plus 4. So there are 7 of these 9's. So we can go ahead and say that's going to be 7 times 9 plus, we have another plus inside here. And then we have 7 of these 4. So that's going to be 7 times 4. Let's go ahead and write that 7 times 4. Now, if we have 7 9, 7 times 9 is 63. And if we have 7 4, 7 times 4 is 28. So 63 plus 28 is going to be 91 here. Okay, so that's going to be the answer to this problem, this expression. 9 plus 4 is 13, and 13 times 7 is also 91. So either way you look at it, it should get you the same answer. For number 4, let's check this one out. We have 3 times the quantity of this 10 plus 4. So 3 of these 10's would be the same thing as saying we have 3 multiplied by 10. We have a plus sign in the middle, so keep the plus sign. And then we have 3 of these 4, so 3 times 4, that's going to be 3 multiplied by 4. So let's see, 3 of these 10's, or 3 times 10 is 30. And then 3 times 4, that's going to be a 12. So 30 plus 12, that would be 42. Okay, if you just added 10 plus 4, that's 14. 14 times 3 is 42, so that checks out. Here's number 5. For number 5, we have 6 times the quantity of 9 minus 5. So we have some differences here instead of sums, but let's go ahead and just do the same idea here. So we have 6 of these 9, so that's going to be representing 6 multiplied by 9. We are subtracting here, and so we're subtracting 6 of these 5's. That's what we're really doing over here. So that's going to be 6 multiplied by 5. And so 6 times 9 first, that's 54. And then 6 times 5 is 30. So we have 20, I think that's going to be 24, right? 54 minus 30, that's going to equal 24. Now if we subtract it first, 9 minus 5 is 4. 4 times 6 would be 24, so that hopefully makes sense, okay? Just another way of writing this. All right, for number 6, we have 9 times the quantity of 6 minus 2, or the difference of 6 and 2. So we have 9 of these positive 6's. If we have 9 6's, we can just write 9 times 6. And then we have a minus sign in here, because that's what we have inside the parentheses. And we have 9 times 2, so we're taking away 9 of these 2's. Alrighty, so 9 times 6 is going to be 54, and then 9 times 2 is going to be 18. And 54 minus 18 should equal 36. And we can check this, right? So 6 minus 2 is 4, and 4 times 9 is equal to 36. For number 7, we have 8 times the quantity of 10 minus 3. So we have 8 of these 10's. If we have 8 10's, we can write 8 times 10. Okay, we have a multiplication there. We are subtracting, because that's the sign we have inside the parentheses, and we're taking away 8 of these 3's. So we have to multiply 8 times 3. So 8 times 10 is going to be 80. 8 times 3 is 24. So we have 80 minus 24. And 80 minus 24 should get us 56. Hopefully that makes sense, because 10 minus 3 is 7, and 7 times 8 is 56. For number 8, we have 7 times the quantity of 8 minus 4. So 7 times 8 first. We're going to go ahead and write those That represents, we have 7 of these 8s, and then we're going to take away 7 of these 4s. Let's go ahead and multiply 7 times 4. All right, so 7 times 8, that's 56. And then 7 times 4, that's going to be 28. 56 minus 28 is actually 28. And so we can check this. 8 minus 4 is 4, and 4 times 7 is indeed 28. All right, let's check out this next set of practice problems here. So here we're going to go ahead and use our understanding of the distributive property. We're actually going to go backwards here. We're going to go ahead and rewrite these expressions that were given. And we're going to write it as the product, which means we're multiplying something, of the GCF. So the GCF is going to have to multiply by something, and it's going to multiply by the sum or the difference of two relatively prime numbers. Okay, we don't have to evaluate here. So here's what we're going to do. We're going to take each of these sums and differences. So on the left side, we have some sums. These are all the answers to addition problems. And then we have some differences over here. But notice that each of these pairs of numbers actually are not relatively prime right now. So we're going to go ahead and find their GCF. So here's what we're going to do. For number 9, we have 16 plus 24, and how we can do this pretty quickly is if we take 16 plus 24, if we know the ladder method, this can be pretty quick here. So 16 and 24, you can say maybe that they have a common factor of 2. I think a lot of people might choose 2 here. 2 times 8 would be 16, and then we just keep a plus sign here. 2 times 12 is 24, and then for 8 and 12, maybe you might choose a 4 here. 4 times 2 is 8, and then 4 times 3 is going to be 12. And so what we can do is keep this in parentheses down here, and then we multiply this 2 and 4 on the side, that's going to get us 8. So we know the GCF is 8 here, so we're supposed to write the product of the GCF and the sum of two relatively prime numbers. So the two relatively prime numbers here are going to be 2 plus 3, right? 2 and 3 have nothing in common besides 1, and if you were to go ahead and check this, 8 times 2 does get us to 16, and then 8 times 3 does get us the 24 that we started with. So this is the product of the GCF and two relatively prime numbers. Okay. For number 10, we have 9 plus 15. So let's go ahead and write 9 plus 15, and we can use the ladder method again here. Now looking at 9 and 15, I'm thinking of 3. 3 times 3 is 9, and 3 times 5 is 15. I think that's it though. 3 and 5 are both prime numbers, so we're done. So the GCF here is going to be 3. So we're going to go ahead and put a 3 out in front. 3 and multiply that by the sum of two relatively prime numbers, so 3 and 5. And we can check this, right? Because 3 times 3 does get us the 9 that we started with, and then 3 times 5 does get us the 15 that we started with. For number 11, we have 24 plus 18. So let's take the 24 and 18, use that ladder method. What we're going to do first here maybe is start with a 3. 3 times 8 is 24. 3 times 6 is 18. And then for the 8 and 6, we can pull out a 2. That would be a 4 and a 3. Let's go ahead and put plus signs between everything over here. And then at the very end, 4 and 3 are neighbor numbers. They're right next to each other, so they have to be relatively prime. 3 times 2 on the side here is going to get us 6, which would be the GCF. So we're going to write 6 times the quantity of 4 plus 3. So we have the product of the GCF, which is 6, and two relatively prime numbers, 4 and 3. So 6 times 4 is 24, 6 times 3 is 18, so this matches what we started with. For number 12, we have 14 plus 21. So we can use the ladder method again here, 14 plus 21. Let's go ahead and set that up. Let's maybe get some more space here. Let's see, I think 7 is going to be a common factor, so we have 2 plus 3 afterwards. 2 and 3 are both prime, so we know the GCF here is going to be 7. So we can rewrite this as 7 times the quantity of the sum of two relatively prime numbers, which are 2 and 3. All right, so if we want to check this, 7 times 2 does get us the 14 we had, and 7 times 3 does get us the 21 that we had. Here's 13. So for 13, we have 18 minus 12, so we have a difference here. So even though we're subtracting, it's going to be the same idea, so don't change your thinking with that. So we have 18 minus 12, just put that into the ladder method here. Let's go and see, I think we can do something like 6, right? So 6 times 3 is 18, and then 18, and 6 times 2 is 12. So we have 3 minus 2. And so they're neighbor numbers, so they must be relatively prime. So we can rewrite this as 6 times the quantity of 3 minus 2. Okay, so checking this, 6 times 3 is the 18 we have at the beginning, and then 6 times this minus 2 gets us minus 12. Okay, so that does work. For number 14, we have 60 minus 45. Let's go ahead and write this as 60 minus 45 using our ladder or cake method. I know they're both divisible by 5, just because they end in 5 and 0. 5 times 12 is 60, and then 5 times 9 is 45. I think 12 and 9 both have something in common again. Looks like 3. 3 times 4 would be 12, and 3 times 3 would be 9. 4 and 3 are neighbor numbers, so we can't go any further. So we have 5 and 3 on the side. 5 and 3 make 15. 15 must be the GCF. And then we have the difference of two relatively prime numbers, 4 and 3. So checking this, 15 times 4 is 60, and then 15 times this minus 3 should be minus 45. For number 15, we have 36 minus 24. So let's go ahead and write this as 36 minus 24. Looks like they have maybe 6 in common, right? 6 times 6 is 36, and 6 times 4 is 24. And then for 6 and 4, I'm thinking 2. They're both even numbers. 3 times 2 is 6, and 2 times 2 is 4. 3 and 2 are neighbor numbers as well. They're both prime. So the GCF 6 times 2 would be 12. We'd have 12 times the quantity of 3 minus 2. Okay, so 12 times 3 does get us 36 that we started with, and then 12 times 2 is 24. And don't forget that minus sign right in between them. Okay. For number 16, we have 52 minus 39. Let's go ahead and put 52 minus 39 on the side here. Using our divisibility rules, I think we can divide 52 by 2 as well as maybe 4, right? 39 can divide by 3. And so 3 times 13 is 39, and 4 times 13 is 52. Okay, so that one was a little trickier to find, but 13 times 4 is 52, and then 13 times 3 is 39, so you may have to do a little division there just to check where I write out a factor list, okay? But 4 and 3 are relatively prime, and 13 is the GCF. So let's put 13 on the outside as our GCF, and then we can put 4 minus 3 as the difference of two relatively prime terms in the parentheses. So 13 times 4 is 52, and then 13 times 3 does get us the 39. All right, let's check out the next set of practice problems here. So from here on, we're going to go ahead and again keep practicing with the distributive property. We're going to go ahead and rewrite each of these expressions as a sum or a difference. Now notice these ones are a little different because they have variables, okay, so keep that in mind. For number 17, we have 3 times the quantity of 2x plus 1. So if we have 3 of these 2x's, 3 times 2x, we're going to go ahead and write that as 3 multiplied by 2 of these x's. And then we're going to say that we have 3 of these positive 1s, or plus 1s. So that's going to be 3 multiplied by 1. Now if we have 3 2x's, 3 times 2, that means we have 6 of these x's. And if we have 3 of these 1s, 3 times 1, that's going to be 3. So that's as far as we can go here. This would be our equivalent expression, and you don't need to go any further. Okay. For number 18, we have 5 of these 6x's, right? So we can go ahead and say that we have 5 multiplied by 6 of these x's, and we have a plus sign in the middle, so keep the plus sign. Then we have 5 of these positive 3s, so it's going to be 5 multiplied by 3. So if we have 5 of these 6x's, 5 times 6, that's going to be 30. Really, that's saying we have 30 x's. And then if we have 5 of these 3's, 5 times 3 is equal to 15. For number 19, we have 2 times the quantity of this 4x minus 5. So if we have 2 of these 4x's, we can rewrite that as saying we have 2 times these 4x's. We have a minus sign here. Let's keep the minus sign. And then we have 2 of these 5's. We're going to subtract 2 of these 5's. So 2 of these 4x's means we really have 8 x's, and 2 of these 5's means we're taking away 10. Okay. For number 20, we are taking half of this 6x minus 8. So if we have half of 6x, let's go ahead and write that. It's going to be half of, which means multiplication, half times whatever 6x's, or half of 6x's, take away, and then we have to also have this half of 8 here. So let's go ahead and take half and multiply that by 8. So what's half of 6x's? Well, half of 6x's must be 3x's, and what's half of 8? Half of 8 must be 4. So 3x minus 4 would be an equivalent expression to half times the quantity of 6x minus 8. For number 21, we have negative 3 multiplied by these 2x's, and then we have negative 3 multiplied by this 5 that's being taken away. So let's go ahead and rewrite this. This is going to be negative 3 times this 2x, and then we're going to take away what? We're taking away this negative 3 multiplied by 5. So that's going to be negative 3 multiplied by 5. Go ahead and put those in parentheses, give them a hug just because we have a lot of symbols going on here. And so if we have negative 3 times 2x, well, negative 3 times a positive 2 is negative 6. So let's put a negative 6x over here. And then we're going to take away, and what's this negative 3 times 5? Well, 3 times 5 is 15, so a negative 3 times 5 must be a negative 15. Okay, so let's go ahead and write that. Now at this point, we have negative 6x take away a negative 15x, but we should go ahead and rewrite this a little bit more simply. So we have negative 6x. Keep in mind that if we keep change and write the opposite of negative 15, we can rewrite this as negative 6x plus a positive 15. So keep in mind we can keep change flip or keep change and write the opposite of the second value here. So you can turn subtraction problems into addition problems. So this would be the simplest way to write this answer. Okay. For number 22, we have negative 4 multiplied by a negative x plus 6. So keep in mind that there is technically an invisible little 1 in front of this x over here. And so if we have negative 4 multiplied by this negative 1x, that's going to be negative 4 times, and I'll go ahead and write it as a negative 1x, just write parentheses to make that a little bit more clear. And then we're adding here, this is now negative 4 multiplied by a positive 6. So let's go ahead and write that as a negative 4 multiplied by a positive 6. Okay, so on the left side here, what's negative 4 times negative 1? Well, negative times a negative is a positive. So that's going to turn into a positive 4x plus, and then what's a negative 4 times a positive 6? Well, 4 times 6 is 24. So negative 4 times 6, so the opposite of 4 times 6 should be negative 24. Okay, now at this point we have 4x plus negative 24, so we have done our distributive property here, but we could simplify this a little bit here, and if we keep change and flip, or write 4x and then subtract a positive 24, this would be the same thing. So if we keep change flip and write the opposite of negative 24, that's a positive 24, then we can turn this addition problem into a subtraction problem written with less symbols. So this would be the most simplified or SimpLEEfied expression to write here. Okay, now dealing with 23, we have 6 times the quantity of negative 7x minus 3. So we have 6 of these negative 7x's. So let's go ahead and write that 6 multiplied by negative 7x. Okay, write that first. And then we're subtracting, so keep a subtraction sign there. And then we have 6 of these 3's over here. So let's go ahead and write that's going to be 6 multiplied by 3. Now, on the left side, what's 6 times negative 7? Well, 6 times 7 is 42. So 6 times the opposite of 7 should be the opposite of 42, or negative 42x. And then to the right here, 6 times 3, that's just going to be 18. So let's go ahead and write minus 18. Okay, so this right here would be our final expression. If you try to keep change flip or add the opposite, we could do that, but that would have more symbols, and we would like less symbols to make it more clean and a little bit less cluttered. Okay, for number 24, we have 3/4 multiplied by the quantity of 12x minus 28. So we have 3/4 times 12x. Let's go ahead and write that first. That's 3/4 multiplied by 12x. And then we're taking away 3/4 of this 28. Okay, so we're going to take 3/4 and multiply that by 28. Okay, now what is 3/4 of 12? Well, if we go ahead and write this on the side somewhere, let's do 3/4 of 12. 12 is 12 over 1. We can go ahead and cross cancel here, divide by 4, divide by 4. 3 times 3 would be 9 over 1, or just equal to 9. So 3/4 of 12, or 3/4 times 12, that would equal 9x. Okay, now what about what's 3/4 of 28? Let's go ahead and write this out. 3/4 of 28, that's 28 over 1. That 4 and 28, because we're multiplying, we can cross cancel. So we can divide this by 4 and get 1. 28 divided by 4 is 7. So 3 times 7 is going to be 21 over 1, which is really just 21. So this 3/4 times 28, or 3/4 of 28, is equal to 21. So we have 9x minus 21 as our most simplified expression, or written as a difference, the answer to a subtraction problem. Here is our last section of some practice problems now. If we go down and check these out, here we're going to go ahead and practice using the distributive property one more time. We're going to go ahead and rewrite each of these expressions as a product of the GCF and then the sum or difference of two relatively prime numbers, okay, or terms in this case. So very similar to what we did earlier, but now we have variables. For 25, we have 9x minus 15. So what we're going to do is just take this 9x minus 15 and use our ladder method or our cake method here. I think we can say that we both have a 3 for both of these terms. 3 times 3x would be 9x, and then 3 times negative 5 or minus 5 would be 15. I think these two terms are relatively prime. 3 and 5 have nothing in common, so we just have this 3 as the GCF. So we can write this as 3 times the quantity of 3x minus 5. Again, if you go ahead and check this going backwards, 3 times 3x would be 9x, and 3 times this minus 5 would be minus 15. Okay, so that does check out. For 26, we have 24x plus 32. Let's go ahead and put that into the ladder method here. And let's see, 24 and 32, I'm thinking of 8. 8 times 3x would be 24x, and then 8 times 4 would be 32. I think 3 and 4 are relatively prime, so we can't go any further. We have this 8 as the GCF, so let's go ahead and put the 8 on the side. And we have 8 times the quantity of 3x plus 4, or the sum of two relatively prime terms. 8 times 3x does get us the 24x we had in the beginning, and 8 times 4 does get us 32, which is what we had. So this hopefully makes sense. For 27, we have 27y plus 36. Let's go ahead and write this down, 27y plus 36. We're using a different variable here, but same idea. 27 and 36, I'm thinking 9 for their GCF. 3 times 9y does get you 27y, and 9 times 4 does get us 36. So 3 and 4 are relatively prime, which means that 9 was our GCF, or is our GCF here. So we can rewrite this as 9 times the quantity of 3y plus 4. Okay, so we have the GCF on the outside and two relatively prime terms on the inside. Checking this, if we had 9 of these 3y's, that would be 27y. If we had 9 of these 4's, that would be 36. All right, for 28, we have 60y minus 45. Let's go ahead and write 60y minus 45 and think of a common factor. Off the top of my head, I'm thinking of 5. 5 times 12y should get you 60y, because 5 times 12 is 60. The y just comes down. And then 5 times 9 is 45, so let's put a minus 9. Now 9 and 12 both still have something in common, right? They still have a 3. 3 times 4y would get you 12y, and minus 3 times 3 would be minus 9. So I think 4 and 3 are now relatively prime. Give those a hug, and this 5 times 3 would be 15 for the GCF. So 15 goes on the side here, and then we have 4y minus 3 as the relatively prime terms on the inside, with a difference of two relatively prime terms. Checking this, 15 times 4y does get you 60y, and then 15 times minus 3 would get you minus 45. So that checks out. Here are the last few. For 29, we have 42x minus 56. So let's go ahead and take this 42x minus 56 and think of some common factor, a common factor for 42 and 56. First thing that comes to mind here is 7. 7 times 6x is 42x. And then minus 8 times 7 will get you minus 56, or negative 56. And then for 6 and 8, I'm thinking of 2. 2 times 3x will get you 6x. And 2 times this minus 4 will get you minus 8. Again, 3 and 4, that's come up a lot, but they're relatively prime. And then 2 and 7 must get our GCF of 14. So we can rewrite this as 14 times the quantity of 3x minus 4. Checking this, 14 times 3x does get you 42x, and 14 times this minus 4 does get you minus 56. For number 30, we have 35y plus 40. And what do they have in common? Well, they both end in 5 and 0, so we could put a 5 here. 5 times 7y gets you 35y, and 5 times a positive 8 gets you positive 40. 7 and 8 are neighbor numbers, so they have to be relatively prime. And since 5 must be our GCF, so this is going to equal 5 times the quantity of 7y plus 8. And can we check this? Definitely. 5 times 7y is 35y, and 5 times 8 is equal to 40. So we're good to go. For 31, these numbers we've seen before earlier in this worksheet or video. So we have 52x minus 39. If you remember, great. If you don't, let me refresh your memory. So turns out that 13 would be a common factor. Remember, 13 times 4x would be 52x, and 13 times 3 is 39. So 4 and 3 are relatively prime. 13 would be the GCF here. So we could go ahead and write this means we have 13 of these 4x minus 3s. Okay, so just remember that 13 times 4 is 52, so 52x here, and 13 times 3 would be 39. Okay, one final one, we have 65y plus 91. So what do they have in common here? So if we put a 13 on the side here, 13 times 5y should get you 65y, and 13 times 7 should get you 91. So 5 and 7 are both prime numbers, so they must be relatively prime. And then 13 would be the GCF here. So if you need to go through and make a factor list, go for it. But otherwise, that would be what we have here as our GCF. So for 31 and 32, 13 happens to be our GCF. So we have 13 times a quantity of 5y plus 7. Okay, just checking this, 13 times 5y is 65y. And 13 times 7 here does get you 91. So everything checks out here. All right, so there we just had 32 different practice problems dealing with the distributive property. Here we went from writing sums and differences as the product of the GCF with two relatively prime terms. Okay, here we did the same thing with variables as well, but we went the other way where we distributed and rewrote the expression as a sum or difference of two terms. Over here, we did it with just regular numbers, and we just rewrote sums and differences using the distributive property. And then right at the beginning here, what we did was we took the product of the GCF sometimes here with each of these two terms, and we distributed and figured out what they were equal to. So hopefully you found this video helpful in understanding the distributive property a little better. If you did, feel free to give it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.